Welcome back. This is chapter 7. This is the fifth video of the series. And in this video, we're going to start talking about two-dimensional arrays. Two-dimensional arrays are just like the arrays that we've been using, except for every element of the array is an actual array itself. I know that might sound difficult, so let me kind of draw that out. So right now we've been having these arrays that look like that. Now imagine, and this is not how it's done in memory, but for the sake of argument, imagine that each element of the array is also an array. And so there, this is an array of 4 by 4. That's a two-dimensional array. It's an array of 4 elements wide and 4 elements deep. So that's what a two-dimensional array looks like. It can define one array for multiple sets of data, like a table in a spreadsheet, which is what we just looked at, what I just drew. It uses two size declarations in the definition. Kind of, we have the rows and the columns, and to do this is exactly how we do it. We specify first the rows and then the columns. So the first declarator is the number of rows, and then the second is the number of columns. So an example of this, and kind of displaying of it, is we've got this constant int row, so imagine that being 4, and then columns 3. So we've got 3 columns with 4 rows. Now this is essentially the opposite of how I drew it previous, but either way you look at it, in the way you want to look at it, if you were thinking of more of an Excel, then this is exactly what it would look like. Either way, as long as you understand that there's rows and there's columns in a two-dimensional array. So in this case, we can also, and just like previous, we're going to use subscripts to access the array. So look at this grid, and you can see the subscript 00 is the very first spot, or the first row, and the first column, right? Or position 00, and so forth and so on. So 22 would be right here. It's going to be the third row and the third column. So what does that look like in a program? Here we have the number of divisions and number of quarters. And so we have our sales grid, or our two-dimensional array, with 3 rows and 4 columns. And with that, we can then output that data. Well, first we need to fill that data in, and then we're going to output that data. Now, when you start talking about two-dimensional arrays, you oftentimes are going to start seeing nested for loops. And that happens, it's one of those things that when it comes to multi-dimensional arrays, oftentimes it's just kind of it goes hand in hand, and you can't do one without the other. So you definitely start seeing that. And again, be careful with that, because as you're going to see here in a moment, we can have more than just 2 dimensions. We can have 3, 4. But as you start doing that, you start getting more and more. You get the 4, then you get another 4, then you get another 4, and the more 4s you have, the more processing your application has to do, the more work it has to do, and it starts to get out of hand pretty quickly. So just kind of be careful with that. But it is kind of, like I said, hand in hand. Two-dimensional arrays are going to have nested for loops, because you're going to have to handle each row, and then in each row, each column. So that's why you have the nested for loops. Even displaying information, or I'm sorry. So this is entering information. This is taking and making the total. Again, you had to have the nested for loops because, again, row, then column. And this is the output of that application. So how do we initialize these arrays? Now, because we specify when we create the array the size of the array, um, one thing we're going to talk about here in a moment is you don't need these inner brackets like this because the system's smart enough to go, well, there's only two rows. So the first, and then of those rows, there's two columns. So the first two numbers are going to be row one, column one and two. The third and fourth number are going to be row two, column one and two again. However, for reading's sake, when developers are, again, reading your own code or reading someone else's code, this looks a lot neater having it this way, and we can automatically see how we're putting our numbers in. But like I said, you can omit those inners. And then if you don't initialize certain values, they will be set to 0 or null. This is where it gets a little bit of fun. When you're using array names and function calls, same thing is, again, what we talked about is you can pass in arrays, and then oftentimes that second variable is the size of the array or the number of elements you use in that array. When you are creating the prototype, you're going to use a blank square brackets for the first for the rows, and then you're going to put in how many columns. So as you can see, in this case, we've got two columns, and this int is going to always refer back to that first set of brackets. And this is the header example as well. Now, why do we do that? Well, I'll show you why. Because remember when we were saying, let's say this is a 5 by 5 grid, but we only use 4 rows. Well, we would pass in 4 here instead of 5. Well, what if I only use 4 columns instead of all 5 columns? Well, this allows us to pass in and utilize, just like we did with rows, how many columns we're using. So this is an example of that show array and how it's being called and how we're outputting the data as well. When it comes to summing all the elements in a two-dimensional array, you have to go through kind of what we were talking about, a nested for loop to do that. So you're going to have this array. This one is 5 by 5. We're going to have an accumulator. Remember what an accumulator is? That is our variable that just holds data for us, and it allows us to, when summing, keep adding to this particular variable. That's why they call it an accumulator. So we're going to send this loop, and we're going to go through the rows, and then for each row, we have to go through every column, and we're going to add that data to our accumulator. When this first row of columns is done, it's going to come back out to this for loop and go to the next row and do all the columns for that next row, then come back out, go to the next row, do all the columns for so forth and so on. So now how do we do an average? Well, similar to what we've done before, we're going to have an accumulator, and then we have to hold the average scores. So in this case, what's going to happen is we are going to sit in a for loop of rows. We're going to set the accumulator, and we're going to, for each row, we're going to add up the total values, go ahead and get the average, which is per row. So the number of scores that we have in that columns, or the number of columns we have in there, divide by what the total number is for that row. That's why we have to set the accumulator back to 0 in for each row, because we're doing row by row. So if we didn't set the accumulator to 0, we would start getting weird numbers for the average. So given the following definition, we can have 3 by 5. We're going to do an accumulator for the total. We're going to hold average scores. And what does that look like? So again, we're for each column. Um, oh, and this is okay. So this is actually going. I was trying to figure out why they were doing it twice. So we're summing the columns now instead of rows. So this was by rows, and this is by columns. So we can do that as well. Again, for each column, we're now going to sit and do each row. We're going to do it backwards, kind of to what we did before. So here's our column loop, and we're going through each column. And for each one, we're going to go through the row and do the same thing as we did before. We have the accumulator that we reset for each column, go through each row, grab the numbers, and now we're going to get the average for that and display it. So now we can have arrays with 3 or more dimensions. You can have as many dimensions as you want. It does start getting a little ridiculous at some point, and your other developers, your team of developers are going to start asking you why. So kind of keep that in mind. Otherwise, it pretty much follows the same rules as the second or 2-dimensional, is you're going to have a new bracket set for each. Think of a third dimension. So we had before, put that in the right spot. Before we had a third dimension, looks like this, rows and columns. Excuse me, that's the second dimension. 2-dimension. When you start talking about the third dimension or third dimensional array, now you're starting to talk more cubed, right? So now you have rows and columns. So we have rows and we have columns, and we have what's known oftentimes as Z, which is the kind of the depth of each one. So that's kind of, and then for each dimension beyond that, it's similar thing. So we have each bracket that holds each piece of data. And same thing as before, you're not going to, in prototypes, you're not going to specify the first dimension in your prototypes. This is the last thing that we're going to look at in this chapter. And this is an introduction to the standard library item called vector. And if you remember back in one of the videos, I think it was last video, I talked about list. And lists look like arrays. They're similar to arrays, but they're not. One of the biggest differences between list and arrays is, remember, arrays, when you create them, are in memory in order. Each space is next to each other, and that's why it needs to know how big your array is, because it needs to find a piece of memory that's sequential enough, has enough space sequentially enough to hold your array. It can't break the array up. A list is different. A list actually isn't in order, and it's not sequential. It can be all over the place in memory, and that's why it. The upside is you can grow this list or this vector. You can grow it without having to copy elements and do all the things that I said before, like you would have to with an array. You can make this keep growing. And also, it's really nice because as your vector gets bigger, it gets harder and harder for the system to find sequential memory to hold, where vector, because it's not sequential, you can have a really large vector and it not be a problem for the system itself. So it's one of the nice things. Now, the downside is arrays are going to always be tremendously faster than vectors. Now, if you're talking small stuff, not a big deal. If you start getting into larger arrays, like I said, I once did an application, and it was about it took the United States and broke it up into a grid, geogrids, and I think there was something like 3 billion grid squares, and so I needed that to be an array because I needed to be able to go through that array really, really fast to process some data. But the problem is that meant I had to have a machine that had a lot of memory and accessible memory because it needed to be able to make that array sequentially. Now, I could have done it as a vector and not had to worry as much about the memory because it could be all over the place, but it would have performed incredibly slower than the array. So there's upsides to both. And most of the time, unless you start getting into really large data, oftentimes people will avoid using arrays and actually start using vectors just because they tend to be a little bit easier to use and manipulate. You don't have to worry about copying data out. Plus, it comes with a whole bunch of functions on top of it. So this is an example of kind of one of those lists. It's called a vector.
Playing from MSP 100216.
Thank you, Alexa. So let's go ahead and talk about it. It is a data type defined in the standard template library, STL. I don't believe we get to chapter 17 in this class, but if you want to learn more about that standard template library, definitely check out chapter 17. It's pretty common now to use those items. It can hold a value of any type. And we're going to specify the type that it's going to hold with these type of brackets, the greater than less than sign. And you can automatically add space as more is needed. So there's no need to determine the size at definition. Just like an array, though, when you want to start grabbing those elements, you'll use the brackets to say which element you want to access. To do this, you're going to have to include this include vector at the top of your code page. This is the precompiler. Let it know that it needs to load the vector file into code behind. And you can declare a vector to hold int values by using that little greater than less than sign and put the int in there. If you want to initialize a vector with a size, you can. So this is declaring it with a size of 30. And you can also initialize all those elements in one quick swoop with that second parameter is what you want to initialize it to. So here we're creating a vector with a size of 30, initialize all those with 0, and it's a type of int. Again, if we need more than 30, not a big deal. And we're going to show you on the next slide how to do that, to increase that on the fly. Declare a vector initialized to a size and contents of another vector. So one of the overrides to the vector is you can give it another. So as we've been all along, we've been creating this vector called scores. Now we're creating one called finals, but we're passing in scores, and this is going to create finals to be the same size and content of this vector of scores. So if you're using C++ 11, you can initialize a vector with a list of values, just like we did with an array. But now we're using this vector, and at some point we need to add items to it. So we're going to use the pushback member function to add element to a full array or to an array that had no defined size. This will automatically add the next, make the vector larger and add that value. The size member function tells you the current size of the vector. So this is something that, when someone passes you a vector in your function, you can find out how big it is by using size. Another nice thing about the vector element, is you can pop back a member which removes the last item from the vector. So if you use this pop back, by the way, it will tell you this is actually going to pass the value back to you, but it's also going to remove it from the vector itself. If you want to clear all the contents of the vector, use clear. And determine the vector is empty, use the empty member function. So here we're saying, hey, do this while as long as scores is not, because remember this is doing the opposite, not empty. Here's a neat little program using a vector, not too complicated. In fact, it's not really giving you much on the vector. because as you saw just previous to the two slides, there's a lot you can do with vector. But we're adding a bunch of items to the vector. Now we're using vector, by the way, which can be used in a range-based loop to go through each item. Here is a list of other functions. So remember now when we're talking in vector, because it is an object, you're always going to have to use that period to then make use of functions inside that vector. And just like we did here, we were talking about the pop back and the clear and the empty. Here's a nice little list of some other useful members. You can find out what the maximum number of elements a vector can store without allocating more memory. You can go in reverse order, you can resize it, and you can swap. And you can also, instead of just using the brackets, you can use at to figure out the position. What's nice about this at is oftentimes you're in a piece of code that you can't, for whatever reason, the brackets, you need to get it by more of a parentheses, like a for loop. For whatever reason, the brackets just doesn't work as well. You can use this at symbol, or this at function. All right, that is it for chapter 7. Take some time, play with the vector function. It is a neat, vector object. It is a neat object. It makes life pretty easy when you are trying to use elements or arrays. Do remember that when you are doing this week's homework, though, just be careful and read the homework. Don't use vector if you're asked to use an array. Because they do function differently, and so if your homework is asking for you to use an actual array, make sure you use an array. All right. Well, thank you for hanging out with me on Chapter 7, and we'll see you next week.